Hi, Internet, and welcome to episode 2 of Open Paren. Today, I will be chatting with Francis Kayiwa, who's a senior Unix administrator at the Virginia Tech University Libraries. Although, as I understand, you are actually embodied by a robot most of the time because you, in fact, live nowhere near Virginia Tech.
Yes, hello. People in Virginia Tech know me as a iPad sitting atop of a telepresence double robotics robot. I travel used to be every 6 weeks. Now it's about every 8 weeks. And I spend a week in Blacksburg.
Cool. So does the robot actually let you move around the library, or your coworkers push you?
So it can. It is a it has an iOS and it has a web browser interface. That is, I drive like I type. So I have this little app that I navigate, and I can say, drive me over here. Of course, I have to have a signal. And if you've ever been in most library buildings, wireless is not particularly good. So oftentimes somebody will actually ferry the robot to a location, and that's how I use it. But I bet you if you go to double robotics elsewhere, yes, you can drive it, and you can. Just that, if you have ever been in most library buildings, you will get to a point where it'll die because it can't phone home.
I'm fascinated by this because I've been full-time telecommute for the last few years working for distributed companies, but I've never had an embodied presence at them. I just use communication tools, right? And so I'm wondering, what are there benefits you get out of having some sort of physical manifestation?
There is. I'm going to sound like I'm selling, double robotics. Please send your paycheck here. I feel like there is, as somebody who started out working in, an office, there is that, I'm in the room, and unlike a phone, unlike, all the other tools that we have, unlike the way we are talking right now, if those 4 other people, there is a robot, and I can make it move so that you actually acknowledge my presence. And in a way that, perhaps in Hangout, people don't, your presence is not necessarily acknowledged in a way that I feel that having the robot allows me. So I think it's great. And for those who are going to be at LIDA, this is the last time I'm going to shill for it. Double robotics. They're actually bringing their product to Minneapolis. So
yes,
you can give that a look-see. I love it. Yeah.
Yeah, I'm hoping to see more on LIDA blog about that, because I know that there's going to be one at LIDA Forum, and I'm hoping that I can experience a little bit of LIDA Forum, since I do not get to go to Minneapolis.
There you go. There's the robot.
I need to talk to people about that, because that would be pretty rad.
Right.
So anyway, I skipped ahead a bit because I was so fascinated by your robot. But I had intended my opening question to be the same one I asked Cecily, based on the Another Round podcast she got me into, because it's awesome, which is, what do you do and why?
Wow. And I did listen to her podcast, and I didn't even do my homework. Says I am as my title suggests, I'm a Unix administrator, and why man, that's going to be a long story. So I was a math and history major, and my roommate my senior year was a computer science major. No, I'll even go back further. In my secondary school, in my high school, we had, I think it was Pascal. Anyway, we had a computer club. Now, I grew up in Kenya. We had a computer club, and you had to go to this tiny room, and you had to sign up. I didn't grow up with computers, but I had access to them in my secondary school. And so I always had this disparaging thing about the computer club. It was, it's like, it's not really a thing that you do. It's the same as the chess club. You don't become a chessician, unless, there's a handful of people who become really good at it. But most of us, you go and you play chess, or you go to the judo club, and then there's a computer club. So I always looked at it as something that people do, you go over there. And I got into it, but as you can imagine, in Kenya, it was highly competitive to get into this club, and I was in it. But the amount of time that you are afforded on, these tiny, circa 1985 computers was very tiny. So you had to come in prepared to maximize your time. And it was a combination of frustration with it. And so fast forward to my university, my senior year, one of my friends was in the computer science department, and he had his own computer in his room. And, this is late 90s. And so, sitting one time with him, and we were just talking about what he does. It's like, oh, that's kind of cool. And, at the time, you'd be able to use email, you'd be able to use Gopher, I think.
Gopher.
Yeah. So it's like, oh, this is really interesting. And it was in access to information. First thing I looked for was, can I get the Kenyan newspapers? And, so I dug in, and, as he was standing behind me telling me all these things I can do, it's like, that's computer science. And so at this point, it's my junior year, third semester. I'm on a scholarship with a sell-by date, and there's no way I moved, all these, there's no way I would be able to turn this into get the computer science degree. So, man, this is long-winded. So I graduate from university. I've literally caught the computer bug. I want in. I want some. And my year, as a international student, you're allowed an extra year on your 4-year visa. I found a friend of mine living in Buffalo had access to computers, and I dove in like both feet. And so the luxury or curse of youth. It gets to about April, and I'm going, my goodness, I have 4 months. My visa is about to expire. I don't know what I'm going to do. And I called my advisor. I don't even know why I thought this. I called my advisor. He's like, well, you're not going to be able to get an H-1B visa with just a bachelor's degree. I can tell you that. Or you can go back to school. It's like, but it's a little too late to apply to go to any to math, to advance in mathematics or history or any of the fields, because you have to have done the tests by now. So, I was in Buffalo, and it was like, oh, library school. So I'm about to out myself as one of those. I went to library school to get a paycheck. So I went to library school. It turns out, there is more to it than met the eye. And because of my interest in computer at this point was still nascent, but I was getting even more into it. I ended up sticking with what I knew, and while I did get the library degree, I felt that because I went in for pragmatic reasons, like I needed to get a job, and the only way I was going to get a job was something to do with computers. And the University of Illinois at Chicago took a chance on me. I will tell you, outright, there's no way I was their best candidate, but they had a residency program, and I fit, certain boxes. And it was at that point that I actually, the 2 years of residency is when I started feeling like a librarian, in a very weird way. It's like, I was going into this because I needed to get another extension on my visa, and I needed to get a job, and I got both. And it was during it was an initial 2-year residency program is when I started to go like, oh, there is a method here. There is deliberateness. There is, strategy about how you manage information in this field. And so I ended up spending 2 years actually getting my library degree while doing the job, and while growing my skills at the same time. So fantastic, inroads into it. And so I do it mostly because I needed a job. I'm actually good at, self-taught Unix admin. I'm actually good at what I do. And so, yeah, I'm pretty sure I haven't answered your question, but yeah, that's who I am, and that's what I do.
That's fascinating, though. I was really reminded when you talked about, coming across the internet and like, oh, this is why computers like matter.
Right.
My alma mater, Harvey Mudd, they have done some high profile work overhauling their computer science curriculum as part of an effort to get more women to major in computer science, which is great, because when I was there were like 2 women computer science majors like in the whole school. And
there is an echo going on.
I can't help you with that.
No, we're good. No, we're good.
Okay. Anyway, when I was there, the school as a whole was 25 or 30% female, but the computer science major was much, much smaller, vanishingly small percentage. And part of what they've done is they've made the freshman computer science, there's a required class, everybody takes it. I took it and it was quite well taught, but never got me to consider majoring in CS. And it's overhauled now, so it's much more focused on like real world projects, which wasn't necessarily possible so much in 1995, right? The tool chain for making a web app is so much better now than it was then, right? But yeah, it was very much like, okay, I've done this programming thing, I can do it, but I don't know what it's for, because the kind of apps you could write after a semester of freshman programming in the mid-90s were just not things that connected to anything I wanted to do.
Correct.
Right. And now which is funny because I was also a math major and I was an extremely theoretical math major, and I haven't gone on in math because I did the kind of math where like literally all you can do is get a PhD and work for the NSA, and like I didn't want to do that. So I don't know why I cared about practical applications, but apparently I did. Anyway, that said, so speaking of practical applications, one of the things you mentioned when you were talking to me before this about stuff you might want to talk about, you gave a whole list of like DevOps support tools, like Ansible and Docker and stuff I haven't even heard of. And I think this is awesome because I know that Docker is the new hotness, but I have no idea why, because I am not in DevOps. So why is Docker the new hotness?
Well, marketing. It really is. You get, venture. I'm being unfair to, Docker. What they're doing was done by Solaris, people who've used Solaris. When the first computer that I logged into at my old university was a Solaris box, and it had zones, and the concept of a container, or the concept of having a I like to think of it personally as an insane padded room where you can do whatever it is that you want. Like, it's not going to affect the person next door. Don't even hear your sound. And I think computationally that has been around for years. I think, I know those zones in this Solaris operating system. FreeBSD had jails, and OpenBSD has the Shroot. And all of these have been done with varying, degrees of, hotnesses. And I'm going to speculate that, they had a problem to solve, and they had, they were running out of, the ability either to license virtual machines, and, they got really clever. And so what the Docker ecosystem does is basically it ships what will appear to you, if you have access to the container, as a, full stack. It's, an entire strip. You'll think you're running an entire operating system, but really you're running, a container inside another, much more powerful Linux operating system. And what it does that virtual machines don't do is it uses the same. So it has a very low memory footprint. So if they're well designed, you can run lots and lots and lots of these, which I imagine is what, I'm not going to remember the people who developed it, is what they were trying to do. Instead of having virtual machines, which you run out of, the virtual machine does actually start to eat up the amount of memory you're using, because if you spin up a virtual machine, it runs at its own environment, it does everything, whereas a container says, like, I only need memory, allocate, and then it passes the responsibility to the kernel. So from a library perspective, or from what we're trying to do, I try to think of, I'm going to use Omeka libraries and digital humanities. Everybody wants an Omeka instance. I can, as coming from the ops side, I'd say, yes, Andromeda, I'm glad you want to set up an Omeka instance, but do I really need to spin up an entire operating system just for you to run your Omeka? It's like, or do I even need to spin up a virtual machine to run up your Omeka? The answers to those is no, no, no. That means now I have two problems. Now I have to take care of your server. Now I have to take care of my server. Now I have to make sure it's patched. Whereas if I have a container, I say, put it in this container, and all I'm worried about is making sure that one server is running. So again, we tend to be powered by lazy, and Docker solves that really well. Docker allows us to use our resources really well, because eventually you're going to run out of virtual machines to license. Eventually you're going to run out of all these very practical problems. And Docker, as an organization, we are just starting to put things into containers. It'll take us about a year. So what we do is we evaluate, we're looking at DSpace. What would we need to do with that? What are the penalties? What are the trade-offs? And we go back to the developers and say, it's like, well, we can put this in a container, but this means you can't do X. Is that worth your while? And I'm starting to talk about DevOps. It's like, that's all it is. It's like, I care about your problem, but I'm looking at the elephant from a different side, a different perspective than you are. So I'll tell them, is like, if we move to Docker, you lose this. Do you care about losing that? Or if we move to Docker, this is the penalty. You don't get to log into a machine like you currently do. Do you care? And what's the impact of that? And then we iterate through that. We negotiate through that. And sometimes you don't get what you want. And using the DSpace as an example, I'm pretty sure we don't have an answer for that. But we continue to iterate through until we come to a place where everybody's happy, everybody knows what they own, what part of the elephant they own, and then we watch it move. So yeah, that's Docker in a very, I'm pretty sure it's weird, speaking to you is like, do I have all my facts on Docker correct? And,
more facts than I have on Docker.
is like, that's what Docker attempts to solve, is that it allows me to be able to say, I'll create one container that has a vanilla Omeka instance, and then to you, you'll think you're logging into a machine, and I don't have to spin up 5 different Omeka instances. I have, a parameterized Omeka Docker container.
Okay. Yeah, I mean, I'm used to solving sort of from the software side, the dependency management problem.
Right.
But it sounds like this is also letting you put a limit on your memory footprint or other things on the more hardware and system side you might care about. Okay.
Yeah, and that you brought up something that's really interesting is, what it allows you, one of the other things that I try to sell when I'm negotiating with developers is, if you have it in a container, you can throw it just about anywhere. So if my data center went down today, you have your container, you put it on Amazon Web Service, you put it on DigitalOcean, you say, you install Docker, and boom, that's all you have to worry about. So if you think about, they describe it this way in their introductory docs. It's like, you have a container that's self-contained. It has everything that you need in your stack. All I would have to worry about is, how do I mount a volume on my storage to say, when her container says var www, what does it actually store that? Where is the persistent data going to be? It's like, so I create a map to that saying, dump it in my storage area network, and your container thinks var www is actually something that lives in the container, but the truth is, through Voodoo, we have a map that says, yeah, that's just going to a storage area network. And, that can now, now that I use the Amazon Web Service, it's like bad example. But, as far as we're concerned, we can tear down that container as long as we map it to the storage. We only have to worry about the storage, and your container can go any place. We'd give you your storage, and then you do the mapping on Amazon Web Service.
So you still got to be doing like database backups somewhere separately, and pointing out to the actual data.
Correct.
But you've got all the software. Okay, that's cool. So you were mentioning like limitations. So I get they can't SSH to a machine because there is no machine. What would be the downsides of using Docker? When would I not want to use it?
It's like, it's one of those, I don't quite fully understand the Linux kernel, and I don't need to. and because I don't fully understand, and because it's really new, it's like, that would be my worry. So its security track record hasn't been tested well enough.
Yeah, I've heard about that.
So again, it's do you really want to be on the bleeding edge with something that is really important to you? My answer to that is no. So I would use, it's like I would advocate. No, again, I'm using it, but I would advocate caution with it. And so, time will tell. We've had lots of things that have come up like this over the years that are the new hotness, and then you look 5 years down the road, it's like, whatever happened to Docker? The venture money runs out, whatever. And so, that would be my number one downside is, again, we are, as an organization, I like the fact that it frees people from depending on me. So if you can learn how to containerize your application, then all I have to worry about is making sure that my Docker is patched. It's like I don't have to do anything. But as from your design perspective, it's like you should worry about will it you're hedging your bet on something that is really it's like if it's the what is that curve, technology adoption curve, is like it and is that would be my number one concern, and it's a real one. I've never looked at the code well enough to say this frightens me, but that would be the downside.
Yeah, I mean it probably does, right? Was the Quinn Norton essay about everything is broken, and like the more you get into software, the more you realize everything is nothing but like duct tape and explosives.
Right. Right. Yeah, you could use that and again, there is enough cleverer people than me who are betting their house on Docker. There's people who are cleverer than me whose house is value is measured on quarters, so they need to make sure that Docker works for them. And so that, having said that, I worry about its adoption rate and not quite fully understanding it. I mean, I understand what it leverages in the Linux kernel, but how they implemented it is something that I always worry about. And it sort of segues really well into, my favorite operating system is, the simplicity. It's like, it feels over-engineered to me. Again, I've never, looked at the actual, well, I've looked at the source code, but it feels every time I look at it, it's like, wow, you really need to do all of this. And the answer is probably yes. In a way that, my, not having a CS background, being able to read and write in C is like every time I look at some of the design decisions with, my OpenBSD, I always, it's like, I get it. I probably could never write this code, but I see, the simplicity of how the operating system itself works makes me feel confident every time the OpenBSD project does anything. It's like I go, it's like, yeah, it's like I've looked, but again, I've also spent, the better part of, what is 2000? The better part of 15 years, working with this. So I have confidence in a way that, Docker is new, and I've never really looked at the Linux kernel to say, yeah, this makes sense. But every time I look at it, it's like, really? Yeah. Over engineered is probably my first reaction, but then again, it works for a lot of people.
So you keep mentioning OpenBSD and your favorite operating system. So I take it these are the same thing. So why is it your favorite?
Most of what I've done with computers is who is my closest friend, and why, who is my closest friend who's an expert, and what do they use? I was at Access in September. Is it September? Yeah, it was September. And I'm going to say their Twitter handles because, my goodness, I'm not remembering anyone's names. Red Librarian and I think Archivalistic did this presentation of how they would do what is the equivalent of pair programming. But I've always had someone like that I can walk down the hall and say, hey, what are you doing? So when I started picking up computing, at the time, it was either access to a Sun Solaris, or as a timeshare, excuse me, or it was, somebody using a variant of Windows, and Linux had just come out. And some of my friends were using Linux, and one of them happened to have OpenBSD. And the very first computer that I assembled for myself, there was something with the drivers that I couldn't install. Slackware.
Yes, because 2000s.
I couldn't get it on. I couldn't get it online, so I fought with it. And one of my other friends down the hall was like, "Just try OpenBSD, works." And by God, it did. It was like, wow, that was it. The install process. I remember just sitting there and going, that was it. And then after you log in, the first thing it tells you, the first thing you log in is, run the afterboot command, and it tells you what you need to do. And for somebody who'd never, had the CS background, who always has a chip of it on his shoulders, always doubting, do I belong here? It's exactly what I needed. It tells me, after you've installed this, the first thing you should type is, I think it's help. It's either help or afterboot. But it tells you all the things that you need to do in order to actually use this operating system. It tells you if you're a system administrator, you really need to do all these things. And it's all contained. I don't have to go, what did we use then? You didn't have to go to IRC. You didn't have, everything that you needed to run this machine was already in there. Plus maybe the FAQs, these things that, they can't package. And that simplicity of, it actually does say, is like, we spend a lot of time writing good documentation, so use it.
It makes such a difference.
Yes, and you will not, I think Django, I think Ansible have, enviable documentation, but you will not find an operating system with as clear, and I mean clear. They write the documentation to make it work. It's you're trying to do this. Here's a synopsis. Here's what you need to do. And you don't have to say, you don't have to make a little prayer. You don't have to make a sacrifice for God on Tuesday in order for it to work. You don't have to do any chants to say, this is what I'm trying to do. And for someone who was just getting up, it was extremely useful for me because there's that I don't understand it, or I don't have the background, or I can understand this, but I don't. The assumption with a lot of the other documentation that you read in operating systems assumes that you already have a CS background. It comes off that way. It's like, what do you mean you don't understand this? It's like, well, I don't. They write in the same, OpenBSD is written for people who want to do what they want to do and get out. Its default is, generally things in the default state will just work. You will say, is like, I just want to add this, or I want to do that, and you'll go and do the knob tweaking, and then you'll walk away. And for someone who always, going back to, always thought of computers as they're really just there to do certain things, and then you walk away and don't have to think about them. It's like, that appealed to me. fast forward, now is like I find myself doing a lot more than I need to. And so yeah, its simplicity was its attraction, and it's reliable. It's just, my God, it's reliable.
It always astonishes me the extent to which man pages are like this genre, and they're,
Right.
they're reference, they're not explanation. So yeah, they do
Right.
expect that you already basically know it. You just forgot. And I just, I think about Linux documentation. I think about man pages, and then I think about ignoring the man pages and finding something on Stack Overflow that tells me what I actually need to know. I've never found that genre readable. And I do think there is this sort of built-in assumption that you do have the person down the hall you can ask, right?
Right.
And I think even for those of us who are, self-taught, which you and I both identify as to at least some extent, like, we had the person down the hall we could ask, right? Like, I'm married to a software engineer. I can always ask questions. And
yeah, it's the ability to express ideas clearly is extremely difficult. The ability to express ideas clearly and simply is very difficult. I fully acknowledge that. It's like I have my own biases when I write. I can't sit here and say, like, I write documentation that actually accommodates you. But having said that, there's people who can do it, and the Ansible's documentation is there. I'd say Django. It's when I started writing. When I started writing programs, Django was my first foray. I used to maintain other people's code, but when I first started actually writing, this is Francis's idea. This is how Francis is going to do it. The closest, I tried. I don't want to say I tried. I exhausted everything. It's like, but I found the hand-holding of the Django project for someone who didn't fancy himself a developer, who will never fancy himself a developer. I can write code, but I'm not a programmer. I found that liberating. It's like, they have, this is how you do this. This means that, and that's key. There's no assumption that you know what object orientation is. It's like, this is the problem Django tries to solve. This is how Django solves it. When you're trying to do the ability to write like that is difficult. I regret that I missed Becky Yo's Code for Lib documentation pre-con, but
it's most of my programming is Django, and definitely all of the tutorials. The tutorial is extraordinary, and the introductory stuff is very good. I have run into things that are not as well documented as I might like, but only because I've really pushed the borders of what Django wants to do at this point. But yeah, shout out to good documentation. Django REST framework, I want to mention them for good documentation, and Stripe, which is the best documentation I've ever seen. The payment processor, thing of beauty. And yeah, I agree. It's like documentation is a form of hospitality. I've said that before. It's
and so to me, it's like I felt immediately comfortable in. Now I've used just about every Unix or Unix-like operating system. To swear at all of them. I swear very little. I swear very little when I'm running my OpenBSD boxes. I know exactly where to get it. And occasionally I'll get frustrated when I'll have to go to the OpenBSD FAQ, but mostly the documentation is self-contained. And I like to say to people is like, you can get on a plane and you'll have all the documentation that you need to run your operating system and not have to be connected. That is my par exemplar.
That's good. So I think we have time to talk about one more thing, and I want to hit on Ansible, because you keep alluding to Ansible, and you mentioned it before, and that's also in the list of nouns that I've heard of and I know nothing about. So what kind of new hotness is Ansible?
So, and it's really I'm mad at Ansible right now. Again, probably unfairly, but they just got bought out by Red Hat. And that frightens me. That frightens me for for reasons that, and I'll bring Java into this. So when I first started using computers, I think at the time all CS schools taught people in Java. And
Late 90s, 97-ish. Yep.
Yeah.
That's when my school switched over to Java.
And so so I was trying to fit in with the cool kids, but only the CS people had access to the Java license. And to this day, I hate Java because of that. I hate Java because, come on, and
I think that is a totally fair and reasonable grudge to nurture for 20 years.
Yes. And to this day, I anytime there is a project like this that just got bought out by Red Hat. Now they already had Ansible Tower as I imagine, their revenue generating stream. And this is why I'm reserving judgment, even though I'm reserving judgment. They had a revenue stream, through Ansible Tower that would allow them to continue to, they have to earn a living, and I respect that. But it just struck me as, this is, no good is going to come out of this. But I'll go back to the tool, which is a better place to spend our last few minutes. The tool itself is brilliant. It's, well documented. I'm trying to do X, and what it is it's an orchestration tool. I administer upwards of 60, 70 servers at any given day. And, what I try to do is, treat them like cattle, and I'm thinking of cattle, and, you prod them, move this way, and they all move. So in terms of security updates, I go to my control machine and I say, Ansible, update all the machines. And it logs in as a privileged user, figures out what operating system is running underneath. If it's CentOS, it'll say yum update. If it's the deb family, it'll say app, it'll run the native tools, and it does that for me. I used to do this with shell scripts. I used to do this with homegrown shell scripts that were not maintainable because my documentation is rubbish. But in Ansible's case, it allows you, without needing to have pre-installed clients in all of the machines that you're controlling. You just use tools that are already built in. So if it's a Ubuntu box, it'll use the apt-get tool. I will use SSH to log into them. I don't need to use a client. I don't need to install a client on all of the machines that I'm controlling. So it's a tool set that I already use if I was managing this as an individual machine. Except what you do when you write what is called an Ansible playbook, you do self-documentation. Now I've talked about how people are great with documentation. I've almost always, this is the first time in my career where I've had another Unix sysadmin. So every time I've managed things, I've managed what I would probably say is very poorly, is that I have all the shell scripts that I've written that will allow me to manage all these machines. But if I was to leave, people are in a world of hurt. Right. Now, I've only been at 2 jobs, and I left on good terms that they can call me, and I'm happy to, clean up the mess that I left and tell them this is what you need to do. Well, this documentation was not clear. But what Ansible forces me when I'm managing these machines is now I document it in a playbook that is written in the YAML language, that it will say, the following step is doing this on these machines. The following step is doing this on these machines. Then I don't have to write it for CentOS. I don't have to write it for Ubuntu. I don't have to write it for BSD. It's like and the Ansible playbook will log in. It'll determine, it'll say, oh, this is an Ubuntu box. I'm going to be using apt for this to update. But this is a CentOS box. I'm going to be using yum to update this, et cetera, et cetera. So it allows you to orchestrate, a fleet. I mean, and I'm saying, I'm using a metric I hate using when I'm comparing tools, is I'm looking at Chef and Puppet, and Chef and Puppet's case, I think if you were managing, and again, I've never had this problem. If you're managing thousands and thousands of servers, you could probably justify Chef and Puppet. I'm not sure. I think Ansible will still hold its own. If you're managing thousands of machines, you would need, Ansible maybe might not scale up. I don't know. I've never had this problem, unfortunately. But for the problems that I need to solve is like I need SSH into the machine. I need you to do the following steps. I document those steps. I write those steps in what Ansible calls a playbook. The playbook will say, go in there, do these steps. If Andromeda is to have a takeover for my job, Ansible forces you to write documentation. It'll say the name of this play is ...
That's really cool. And because it's saving you so much time on the back end,
right.
The documentation isn't.
Right. It's plain speak of, this is logging into these machines. It's using, you don't even have to know anything about CentOS if I give you a playbook. It's like, the Ansible tool will log in, it'll know this is CentOS, it'll know, look for yum. So it forces discipline that I perhaps didn't always have as a system administrator. And it guarantees that all of your servers will be doing, hang on a second, killing noise that is you can't hear, but I can. So it guarantees that when I ran my updates this morning, I know that all of them were updated because it reports in the playbook that yes, I've logged into all of them. None of them needed updates. Some of them did, and these are the 2 that changed, and I'm done. And my shell scripts used to do that, but there was always the if it's this, right? That if it's that, so I'd have multiple, logic, built into the system. So Ansible is liberating, and it has just about a module for everything and anything you could ever think of. And this is my fear with that purchase. People are writing, the built-in modules will allow you to do everything that you could ever need as a system administrator. But there is also an ecosystem that is built for, it's an open source project, for just about anything, things that I never even thought of. It has VMware modules that people have written that will allow you to do everything that a system administrator does. And I suspect that that's going to go the Red Hat route, or I speculate wildly that it's going to go the Red Hat route where you have to pay to get some of those things. So I hope it doesn't affect me, and I'll stick with it. There's other tools. There's a Perl-based one which I used to use, not as much as I would have liked. Rexify, which does the same thing that Ansible does. It's a Perl-based tool. But yeah, that's a problem that it tries to solve, and it allows, if you had a junior system admin, that's a good way to train them. Is just look at this playbook, see what it does. It forces you to document it. It keeps people honest and all your servers behaving like they can.
So it sounds like you've just described a robot for owning all of your servers, which definitionally has root privs. So how do you make this not terrifying?
Well, you can prevent that. Ansible allows you to prevent that. In most of the things that I do, so I will describe my environment so everyone can try and come and break in. We have a deployment user. So you've written your application and it's stored on GitHub. So we'll create a deployment user that is only allowed to do the updates. And then if it's for system updates, it's key-based authentication. It's restricted to one IP. So that's you can't log into the control machine. I can. If you break into my you can't break into my machine. But if you do break into my machine, then we're in a world of hurt. But by and large, it's no different than if you if you break into my laptop. And you can limit what the Ansible. Wait, what was your question?
How come this robot for owning all of your machines with root privileges on everything?
Yeah,
it's not terrifying.
It's not terrifying because it's the same thing if you were to ever get a hold of my laptop. I use SSH keys to log into them, and it's no different. Let's call it Francis's agent. You should be as terrified of it as you would be as terrified if you ever got a hold of my laptop. Then you have access to all of my boxes. So I'm not too terrified of it. By design, we allow it to only log in from one machine. Now logging into that machine is, we make sure that only certain people can log into it. And it is, if you practice, if you do good practices, you will be fine.
Okay. Well, this has been fun. I think
it has been less
it's been most of an hour, but
yeah, less terrifying than I thought I should add.
Yeah, you shouldn't be terrified. You're a fun storyteller. It's always a good time talking to you. And I got to learn about lots of stuff that I didn't really know anything about, which I am realizing is one of my favorite parts of this podcast. There are many, but I get to go to cool people and be like, I know nothing about your work, but it sounds awesome. Tell me more. Yeah, so thank you for your time. I'll let you get back to the rest of your day. Thanks, Internet, for listening or watching, however you do. Until next time.